Alright, till this lecture, in this section we have learned different features and types of big O. Now in this lecture, we will look at how to measure time complexity of codes using big O. To make our life easier, I have created a list of rules which will help you to analyze any code. So these are the rules that we need to analyze any code. So the first rule is any assignments or if statements that are executed once, regardless of size of the problem, will take O1 time complexity. So this means that if we are doing an assignment in our codes and if you write if conditions, the time complexity for these expressions will be O1. Now the second rule is a simple for loop from 0 to n without any internal loops will take On time complexity. This means that if you are looping through any given array or any given string, if the number of elements in the string or in array is n, so this will take On time complexity. Then this third rule is a nested loop of same type takes quadratic time complexity. So in this case, it takes On square time complexity. This means that if we have two loops inside each other, as we showed in our previous lecture in case of multiplication, so this will take On square time complexity. Now the fourth rule is a loop in which we are controlling parameters is divided by 2 at each step, then it will take O log n time complexity. This means that in this case, we are not looping through all elements of the given object. So we are looping through only some elements of the object. So that's why it will take O log n time complexity. And the fifth rule, which is the last one, is that when dealing with multiple statements, we are just adding them. So these are the common rules that you need when you analyze any given code. Now let's see these rules on given example. Now we have an array like this. In this array, we want to find out the biggest number. So in this case, we can write our function in Java like this. So this is a function. So this function is responsible for finding the biggest number and printing out to the console. Now, as you can see, it takes as a parameter sample array. Then we are initializing a variable and setting the first element of array to this variable. Then starting from the second element, we are looping through the array, and inside the loop, we are checking that if the current element is bigger than the biggest number that we created over here, then we are assigning this number to the biggest number. And it continues like this until we reach the end of the array. Now let's examine this. What is the time complexity for this method over here? Now when we are calculating the time complexity of a method or a block of code, we are always starting from the first line of code. So in the first line, we have assignment over here. We are creating a variable and assigning value to it. Now according to our first rule, it says that any assignment statement take O1 time complexity. So this means that the first line of code over here will take O1 time complexity. Now, then we are continuing to the second line of code. So in the second line of code, we have loop over here. So according to our second rule, it says that a simple loop from 0 to n will take On time complexity. So it doesn't matter it starts from 0 or 1, it will take On time complexity because we have to loop through array until we reach the end of this array. Now, inside loop, we have if statement over here. So we know that according to our first rule, if statement takes O1 time complexity, then inside if, we are assigning a new value to the biggest number. So this means that this will also take O1 time complexity. Now at the end, we are printing out this biggest number to the console. So this means that it will take also constant time complexity, which is O1. Now we have found time complexities for all these lines over here. Now it's according to our fifth rule, so we have to add them together. Now we'll start from here. So here we have O1 time complexity and O1 time complexity. If we combine them, it will get O1 time complexity because O1 plus O1, it will be 2O1. So we are eliminating constant term, it becomes O1. Now, then we have to join On with O1. So when we combine them, in this case, O1 is non-dominant term. So we are eliminating O1, it becomes On. Now at the end, we have to combine all these three cases over here. So O1 plus O1 will be On because in this case, O1s are non-dominant terms, so we can easily eliminate them. So it becomes On time complexity. Now this is how we are finding a time complex for a given code. So hopefully you have understood the concept, and with the help of these rules, you can find the time complexity for any given code. So see you in the next lecture.